I did forget to mention in the last video, this said indefinite integrals up here. Right now, we're only working with what are called indefinite integrals. We're going to learn in a later lesson what definite integrals are. So for now, that doesn't have a lot of meaning. When we have definite integrals, then we will have a better understanding of the difference between the two. So let's look at 4 examples. We have evaluate each of these. The first one is the integral of 3 cosine x dx. We can use that first kind of, or the second rule up front, where we can actually take the 3 out front, that constant, and we just have 3 times the integral of cosine x dx. Notice I still have the integral and the dx there because I haven't integrated yet. And then we know the integral of cosine is sine. So we have 3 sine x, because the integral of cosine is sine, plus c. One important thing that I do want to note is you do have to write the dx here when you write out an integral expression. If you do not write that dx in HL, you do lose a mark. In SL, they won't usually take off a mark generally, but in HL, they care about those details. It does matter. You do have to tell what variable we're integrating with respect to. The next one, we have the integral of x cubed plus x squared dx. And so we're actually going to use, I want to get rid of that blue line. Ignore once. Here we go. We're going to use that rule that says we can just find the integral of each of those separately. It's the integral of x cubed plus the integral of x squared. We're not going to write both of those out. We're just going to do it. And to find the integral of x cubed, we're going to use the reverse power rule. The reverse power rule says add 1 to the exponent. Notice I'm not writing the integral symbol anymore because I am integrating now. Add 1 to the exponent, and then multiply by the reciprocal of that new exponent. The reciprocal of 4 is 1/4. You could also write that if you wanted to as x to the 4th over 4. That's how it looks in the formula book. It's the same thing. I usually just like to write 1/4 in front. That's my preference, but they are the same. And then we have plus, add 1 to the exponent, x cubed, and then multiply by the reciprocal in front, 1/3. Or, like in the formula book, it says divide by your new exponent, like so. Either of those are fine ways to write this. Okay, C. You may notice for C, we're going to have to simplify a bit first. To simplify first, you have a couple of ways to do this. We've seen these actually when we differentiated simplifying. I'm going to just divide each term by t to the 5th power. So that's the same as t cubed over t to the 5th minus 3t to the 5th. I'm writing it out the long way over t to the 5th dt. And again, I'm still writing the integral because I haven't integrated yet. I'm going to simplify first. So if I simplify this, this becomes 1 over t squared, which is t to the negative 2 power, minus t to the 5ths cancel, so minus 3 dt. And then I will integrate this. I'm going to add 1 to the exponent. If I add 1 to negative 2, that gives me negative 1. And multiply by the reciprocal of negative 1 in front. The reciprocal of negative 1 is negative 1. So that just becomes negative t to the negative 1 minus, what's the integral of 3? The integral of 3 is 3t. Oh my gosh, I just said I never forgot plus c's, and I did on that last question. You usually don't forget plus c's. I'm not going to forget it on this one, plus c. Okay, the integral of 3 is 3t. You can actually, if you want to, kind of think of this as t to the 0 power on the original, minus 3t to the 0. We're adding 1 to the exponent, t to the 1st, and dividing by 1 out front. Or you may just think that, well, you know, the derivative of 3t is 3, so the integral of 3 must be 3t. Again, you'll get used to these with practice. The last one, feel free to try on your own, but you're going to run into a bit of a problem if you do. I'm going to simplify first, just like I did the last one, and I get x to the negative 1 power plus 5x squared dx. We're going to run into a problem with x to the negative 1 power because if I add 1 to the exponent, that gives me x to the 0 power. Well, x to the negative 1 power, look back up at your rules. That is actually one of your special rules. That is the same as 1 over x. The integral of 1 over x is the natural log of the absolute value of x. That's probably one of the trickiest ones for students to remember, to recognize, but hopefully when you start trying to add 1 to the exponent, you see you have a bit of an issue and you realize that something strange is going on, and then it clicks in your head that that's the natural log of absolute value of x, plus add 1 to the exponent, and then divide by that new exponent, so divide by 3. So I'm going to write 5/3 out front, plus c at the end, that constant of integration. And there we go.